Hello friends, now we'll be talking about quadratic equation. If you have gone through the pair of linear equation in two variables, I've also talked about what do you mean by linear equation. Linear equation are those where the power of the variable is 1, that is degree 1. Now if I have, see, if you look at the second equation, you will see among the x, the power of x, the highest power of x is 2, which is square. The degree of this equation is 2. Then such equation where the degree is 2 will be called as quadratic equation. So we'll be studying about this. And you should remember one thing is, when we talk about linear equation, the value of the variables are called the solutions, and when we talk about quadratic equation, the value of the x, the variables, are called the roots, because we'll have one value, one number, which will satisfy a linear equation, so we call it as solution. But in the case of quadratic equation, there will be two numbers which will be satisfying the equation, and these two numbers you can use any one of it, but we'll get two values, so they are called the roots of what? The quadratic equation. So starting with the general expression, so the general expression of quadratic equation is ax square plus bx plus c, this is equal to 0. So the general expression for linear equation in the chapter pair of linear equation, I have talked about it. So this is equal to ax plus by equal to c. So likewise, the general expression for quadratic equation is ax square plus bx plus c equal to 0. Now let's find out the roots. How do we find out the roots or the values of x? So we'll be using what? Completing the perfect square. So I'll be multiplying, I say this is equation 1, I'll be multiplying this equation by 4a. So multiplying this equation by 4a, so it becomes 4a square x square plus 4abx plus 4ac, this is equal to 0. Now the first term can be written as 2 square a square x square plus 4abx plus 4ac, this is equal to 0. So since all the exponents are same, I can take out the exponent 2 common and write it this way. The first term becomes this. So the algebraic idea, a square plus twice of ab plus b square, a plus b whole square, I want to use this. So our first term is twice of ax. So in the second part, I'll modify to get the first term. So I have 2 into twice of ax, this is our first term. So b comes out. So you see I have a square, or I can use b square plus twice of pq. So our q is equal to b, so I need to complete the perfect square, I need b square, so that will be equal to q square. But in this equation you will see we don't have b square, so we need to remove because we don't have it. So I'll just remove by adding minus b square. So far it is fine. I am removing b square because it is not there in the previous equation, but what is there? Plus 4ac is there, so I'll add plus 4ac, this is equal to 0. So now p square plus twice of pq plus q square is equal to p plus q whole square, our algebraic expression. So you will see this expression is present here till this part, so I'll use this algebraic expression to express. So it becomes twice of ax plus b whole square minus b square plus 4ac. So if I transfer this on the other side, so I'll have twice of ax plus b whole square, this is equal to b square minus 4ac. Now taking square root on both sides, so it becomes twice of ax plus b, this is equal to root over b square minus 4ac plus minus y plus minus, let's say if I have root over minus 2 square, this is minus 2. If I have root over plus 2 square, so this is plus 2. So whenever there is a square root, it can have negative and positive, so I can write plus and minus in front of root overs. Okay, so if I transfer b on the other side, it becomes twice of ax. This is equal to minus b plus minus root over b square minus 4ac. So finally I have x is equal to minus b plus minus root over b square minus 4ac divided by twice of a. So I have the value of x to be x is equal to minus b plus minus b square minus 4ac divided by twice of a. Earlier also I've said, in the case of quadratic equation, x will have two values and they are called roots. So x will have two values because plus minus is there. So the first root I defined as alpha. Alpha is equal to minus b plus root over b square minus 4ac. Okay, and beta is equal to minus b plus or minus root over b square minus 4ac. Okay, so this root means if I replace them in this equation, so left hand side is equal to a alpha square plus b alpha plus c. This will definitely become equal to 0, so it will be equal to right hand side. So alpha and beta are the values of x which will satisfy our quadratic equation. Now we'll be talking about the discriminant. Discriminant is the discriminant of a quadratic equation is equal to b square minus 4ac. This is a very important term because using this without actual calculation, you can tell the value of the roots, or the nature of the roots, how the nature of the roots will be. So using this b square minus 4ac, I can say first case, if b square minus 4ac is greater than 0, that means there is a quadratic equation and say you find out the value of b square minus 4ac equal to 0. Say for an example, I have a quadratic equation x square minus 4x plus 1, this is equal to 0. So what will be the nature of these roots? So comparing this with the general expression, I'll have a is equal to 1, b is equal to minus 4 and c is equal to 1. So b square minus 4ac is equal to b is minus 4, 4 square minus 4 into a is 1 and c is also 1. So I have 16 minus 4, that is 12. So 12 means positive. That means our b square minus 4ac is greater than 0. It is positive. So in this case, what will happen is, if the discriminant is greater than 0, the roots will be distinct. That means the two value of x will be what? Not same. Okay, they will not be same, they will be completely different from each other, and the nature of roots will be real. Okay, the nature of roots will be real and the roots will be distinct. That is, alpha and beta will not be equal when the discriminant is greater than 0. Now the second case, if the discriminant is equal to 0, if the discriminant is equal to 0 in the second case, then what happened? Then again the two roots alpha and beta will be equal if the discriminant is equal to 0. So the roots will be equal, and number 2 conclusion that we can make is the nature of roots are real. They will be real numbers. Now the third case. In the third case, the discriminant will be equal to negative, that is b square minus 4ac is less than 0. So that means 0 is greater, means b square minus 4ac value will be coming out to be negative. In this case, the two roots will have an imaginary number, or I can say they will not have real roots. So you will not get an answer, or the value of x will not come if the discriminant is less than 0. So before solving this quadratic equation, if you can find out b square minus 4ac, and if it is coming out to be negative, then you can just leave that quadratic equation, because you will not be getting the value of x. So you will get the value of x only in the case of when the discriminant is greater than 0 or positive, or the discriminant is equal to 0. Otherwise, if this case comes, then you will not get the value of x. So in the next slide, we will be talking about how we'll be using these roots to express a quadratic equation. So now, earlier we have derived the root value of alpha, that is minus b plus b square minus 4ac divided by twice of a, and the second root is minus b minus b square minus 4ac divided by twice of a. Now sum of roots, if I add these two roots, sum of roots is represented by alpha plus beta, that I'll be adding these two. So minus b plus b square minus 4ac divided by twice of a, plus this one minus b square minus 4ac divided by twice of a. So you will see in these two terms the denominators are same, so I can take common, it become twice of a. So the numerator is minus b plus b square minus 4ac plus minus b minus b square minus 4ac, bracket close. So when I open this bracket, it is positive, so it becomes minus minus. So now finally I have b plus b square minus 4ac minus b minus root over b square minus 4ac divided by twice of a. So this and this cancel, so minus and minus added, so minus twice of b divided by twice of a, 2 cancel, so I have minus b by a. So the sum of roots alpha plus beta is equal to minus b by a. You need to remember this. Now we'll be multiplying the roots, product of the roots, we'll be finding out product of the roots. We have just found out that sum of roots is equal to minus b by a. Now product of the roots, so product of the roots, this is alpha into beta, so I'll be multiplying these two. So I have minus b plus root over b square minus 4ac divided by twice of a into minus b minus root over b square minus 4ac twice of a. So denominators will be multiplied and numerators will be multiplied. you will see the numerators is in what form. This is say x plus y and this is x minus y. So algebraic expression for x plus y and x minus y, this is equal to x square minus y square. So using this idea, the numerator can be written as minus b square minus root over b square minus 4ac square. So this and this cancel, root over divided by 2a into 2a is 4a square. So opening the bracket, I have b square minus b square plus 4ac divided by 4a square. These two cancel, so I have 4ac divided by 4a square, 1a and this cancel, 4 cancel, so the product of the root is c by a. So I have product of the roots to be equal to c by a. So how do I use the product of the roots and sum of the roots to express our quadratic equation? So the general expression of our quadratic equation is ax square plus bx plus c equal to 0. Now what do? I divide throughout the term by a. So I have ax square by a plus bx by a plus c by a, 0 by a. So 0 by a is 0. So this cancel. I have x square plus b by ax plus c by a, this is equal to 0. Now in the sum of the roots there is a negative part, so I express this as minus and minus b by a. Slight modification is done. So when I open this bracket, minus into minus become positive, so it remains the same, no problem. So what do you see? Minus b by a is what? The sum of the roots, and c by a is product of the roots. Using this expression here, I'll have x square minus, yes, alpha plus beta, sum of the roots, x plus product of the roots. So finally we have this. So if you know the two roots, you can create a quadratic equation. Okay, so the coefficient of x will be sum of the roots, and the coefficient, the constant number will be equal to product of the roots. This is how if you know, if the values of the roots are given, we can create a quadratic equation. So this is our chapter, quadratic equation.